Deductive reasoning. I first mentioned deductive reasoning in the very first lesson of Unit 2 on logic and reasoning. We talked about the difference between inductive reasoning and deductive reasoning. Remember that inductive reasoning is using patterns and observations to make conjectures or draw conclusions about what you've seen. Deductive reasoning, on the other hand, uses facts and given statements, so mathematical facts or scientific facts. Our essential question today is, how do I use the rules of deductive reasoning? All right, so deductive reasoning is the process of reasoning logically and drawing a conclusion from given facts and statements. I'm not going to highlight deductive reasoning because it was a note card back in lesson 1. Okay. We do have a new symbol today. This symbol stands for therefore. We use it when we're drawing a conclusion. Okay, that one does need to be a note card. So our first rule in deductive reasoning is called the law of detachment. Law of detachment. There's a note card for you. Okay, so with the law of detachment, we often abbreviate that LOD just for convenience. Okay. The symbolic notation says given a conditional statement. So let's see, P, then Q. If the hypothesis is true, we would say P, then the conclusion is true. Therefore, Q. This is sometimes called a direct argument, and it's what we call valid reasoning. Now, it's important to pause for a minute and talk about the fact that valid and true are completely different things. All right, so let's think about something that I could do the law of detachment. If I study, then I will earn an A. I studied, therefore I earned an A. Okay, hopefully that's true for you on the upcoming unit test, but not necessarily. Sometimes you work pretty hard and you still don't earn an A. We can also do this with complete nonsense. If a crocodile is pink, then it has purple polka dots. The crocodile is pink, therefore it has purple polka dots. That is completely a false statement. However, mathematically, it is valid reasoning. Okay, so it follows the rule, and that's what makes it valid. Valid and true are not the same thing. I can't stress that enough. All right, I highlighted the fact that the reasoning is valid and the symbolic notation because that's what needs to go on your note card for law of detachment. The Venn diagram is something that you see sometimes, and honestly, I don't care about it. But there it is. Ooh, my smartboard won't turn the page. I have to walk over to the computer here. Okay, law of contrapositive. So the law of contrapositive, which will be another note card, and you need to put the type of reasoning and the symbolic notation on there. We often abbreviate that LOC, law of contrapositive, and it says given a conditional statement. So if P, then Q. If the negated conclusion is true, not Q, then the negated hypothesis is true? Well, let's stop and think about that for a minute, right? A conditional statement is if P, then Q. The contrapositive, switch and negate. Not Q, therefore not P. Remember that your conditional statement and your contrapositive are what we call logically equivalent. So this is making some sense to me. If I could do the law of detachment with a conditional statement, I can pretty much do the same thing with the contrapositive of the statement because I have logically equivalent statements here. This is sometimes called the indirect argument. And this is also valid. So let's see. If I clean my room, then I may go to the movies. I did not go to the movies, therefore I did not clean my room. Indirect argument. Okay, and the law of contrapositive. On the SOL, you will see it as the law of contrapositive. Okay, and the Venn diagram, again, I don't care about it. Looks like that. Law of syllogism is up next. The law of syllogism should remind you of something from Algebra 1. All right. Law of syllogism will, of course, be a note card. And we're going to include the type of reasoning and the symbolic notation. We often abbreviate it LOS. Okay. So it allows you to draw a conclusion from two conditional statements in which the conclusion of the first becomes the hypothesis of the second. Let's stop and think about what this looks like. So a conditional statement. Now this conclusion has to become the hypothesis of my second statement. And now I need a new letter. So if P then Q, if Q then R, therefore if P then R. What does this remind you of? Hopefully it reminds you of the transitive property from Algebra 1. Okay, so let's think of an example here. If I clean my room, then I will go to the movies. If I go to the movies, then I will get popcorn. Therefore, if I clean my room, then I will get popcorn. Okay, so this is sometimes called the chain rule. You'll see it as the law of syllogism on the SOL and on your test, but some textbooks do call it the chain rule. It is valid reasoning. And the Venn diagram for this, which once again, I don't care for, but we'll put it in here just so that you have it, looks like this. All right, so we had three types of arguments that are valid. Remember, valid and true are not the same thing. Now we're going to have two types of arguments that are invalid. The first one is going to be converse error. The converse error occurs when you're using the law of detachment or the law of contrapositive. And again, it's invalid. So we start with a conditional statement. How do we write the converse of a conditional statement? Remember, converse starts with CO. CO, change order. So I'm going to switch these. If I study hard, then I will earn an A. I earned an A, therefore I studied hard. Maybe, maybe not. Maybe you got the A and you didn't have to put any work into it. Okay, so converse error. The Venn diagram for this, which I don't really care about, looks like that. Converse error is invalid, and it's kind of nice. The word error is actually in the name of this rule, which helps you remember that it's invalid. Inverse error. Converse and inverse. Converse and inverse. Aren't those two logically equivalent to each other? Kind of makes sense. The conditional and the contrapositive were both valid. The converse and the inverse both produce errors. So the logically equivalent statements go together in deductive reasoning. That's an important note to make to yourself. This one also occurs when you're using the law of detachment or the law of syllogism, and it is invalid. So we have a conditional, and we're going to do the inverse of it. Not P, therefore not Q. If I study hard, then I will earn an A. I did not study hard, therefore I did not earn an A. Maybe that's true, maybe that's not. I mean, the reality is some people don't study very hard and they still get A's. Teachers wish that wasn't the case because we would like to be able to say there's the perfect correlation between the two events, but there isn't. Let's be honest. Okay, once again, I don't care about the Venn diagram for this, so you don't need to bother to memorize that. So let's try a few of these. Use the laws of deductive reasoning to give a valid conclusion. Name the type of reasoning used. If not possible, write no valid conclusion and name the type of error. Okay, if Mark saves $30, that's my hypothesis. Then he can buy a new video game. That's my conclusion. Mark saves $30. Is that the hypothesis or the conclusion? Smartboard trauma down here. That's the hypothesis. So if I write this out symbolically, I have P, then Q. P, therefore Q. This is the law of detachment. And my conclusion would be, therefore, he can buy a new video game. All right, let's look at number 2. If you are 18 years old, then you can register to vote. Olivia is not 18 years old. And that not, I'm going to pick up a different color. Okay, let's look at this symbolically. If P, then Q. Olivia is not 18 years old. That's not P. Therefore, and I need to move this board, which is not cooperating. Give me just a second here. So following our pattern, not P would be followed by not Q, right? That's inverse, and inverse is an error. Inverse error. So what would we say here? There's no valid conclusion. I'm not going to write anything because I can't come up with anything that is mathematically valid. If you plan to attend prom, then you must purchase a ticket. You don't plan to attend prom. I'm going to pick up a third color here because of the don't. All right. Conditional, if P, then Q. You don't plan to attend prom. Not P. Therefore, not Q. Another inverse error. No valid conclusion. All right. Number 4. If a quadrilateral is a rhombus, then it is also a parallelogram. So, is a rhombus. It is also a parallelogram. The quadrilateral is not a parallelogram. I'm going to circle the word not here. All right. If P, then Q. Not Q, not P. Law of contrapositive. Therefore, the quadrilateral is not a rhombus. Okay, I like to use a combination of color and the symbols when I do these statements. It just helps me pick out what I'm dealing with. All right, another way to do it, instead of using the colors, is to write the P's and Q's on your statements. I find that gets really, really messy for me though. So using color to identify the hypothesis and the conclusion, circling or using a different color when a negation occurs, and writing the symbols to the side really help me figure out what's going on to get the question right. All right, let's look at the next problem. And sadly, I have to walk over here to turn the page. All righty. If it is Saturday, then Jonah has a hockey game. Story of my life when you have a child who plays sports. If Jonah has a hockey game, ooh, that's my conclusion, coming back as a hypothesis, then he will need to pack some snacks. All right, let's write this out. I have a conditional statement. Then my conclusion comes back as the hypothesis, and I have a new conclusion. That's looking like the law of syllogism to me. LOS. Therefore, if it is Saturday, then Jonah will need to pack some snacks. Alrighty, if you shop at Target, then you use your Target Red Card. If you do not use your Target Red Card, I better circle the word not here, then you will not get 5% off. All right. And I've got the word not here also. So let's see what these symbols say. I've got a conditional, but then the conclusion is negated, and I have a new negated statement. Is that the law of syllogism? No. In order to be the law of syllogism, these two have to match up perfectly. See up here how they matched up perfectly? Because they're not matching up perfectly, there is no valid conclusion, and there isn't a name for this type of error. It's unnamed. No special names when the law of syllogism goes wrong. All right, so at this point, I need you to write me a summary. Make sure you include the 3 valid types of arguments and the 2 invalid types of arguments for deductive reasoning. I would also include the symbolic notation in my summary.